Good afternoon, everyone. So at this time, we'll tackle on statistics and probability 11. So we have here some problems on estimating population mean and population proportion, and also we incorporate also sample size determination for population and proportion. So we have here the following problems that focusing on this one, estimating and determining the size or the sample size. So we have here the first one, problem one. We have here established given confidence interval for the population mean when a randomly selected sample of 15 observation was made with a mean of 23.8 and a standard deviation of 3.4 to compute the following. So we have here, we are given the note that we have to use the t-test table. So actually in estimating the confidence interval or in computing for what? For estimating the population mean, so we will have to use the t-test, particularly if n is less than 30. But if n is from 30 or in above, so we will have to use t-test. So because our n in here is 15, so we will have to use t-test table, provided that we have the sample mean or x bar, which is 23.8, and we have the sample standard deviation of 3.4. So we have to solve for letter A and letter B. Letter A, we have 95% confidence interval for the population mean. Then letter B is 90% confidence interval for the population mean. So I will solve only for letter A, which is 95%, because this letter B will be left as your activity. So solution for letter A, given we have x bar is 23.8 and the sample size we have 15 as our value of n, and the standard deviation is 3.4. Of course, because we are asked to use the t-test table, so we have df, that is referring to degrees of freedom. So that is computed as n minus 1. df is equal to n minus 1, or 15 minus 1, which is 14. Okay, after that, we also have here the formula in estimating the population mean. We have x bar minus t sub alpha over 2 times the quantity of s, that is referring to our sample standard deviation, over square root of n, less than population mean less than x bar, or that is sample mean, plus t sub alpha over 2 times the quantity of s over square root of n. So of course, before we can solve it, as figure out also where these quantities can be found. So our x bar is referring to our sample mean, that is actually given. But our t sub alpha over 2 is not given, so we will now be using the t-test table. Okay? So to compute for t sub alpha over 2, that is under letter A, 95%. So to compute, we have 1 minus 0.95. This is actually the process. 1 minus 0.95 over 2. So our equivalent, we have t sub 0.025. That 0.025 is referring to our actual area in the t-test table. No, that is not the actual area. We have to pair it with the df, or the degrees of freedom. Then finding the intersection between 14 as our degrees of freedom and 0.025. So that is our actual value for t sub alpha over 2. Okay? So accordingly, we have 0.025 and degrees of freedom is 14. It corresponds to a t value of 2.14. So let us now see the table on how this 2.14 being obtained. So we have here, this one is the table for t-test. The first column, we have df, that is degrees of freedom. Then for the first row, that is referring to the alpha value. So we have 0.40, 0.25, 0.10, as what we observed in our previous step, that we do have degrees of freedom of 14, and we have 0.025. So if we're going to get the intersection between 14 and 0.025, so we have here, okay, as being illustrated in the red arrow. So we have 2.14 as its value for the DF of 14 and for the 0.025. Okay? So we can now make use of this formula. X bar minus T sub alpha over 2 times the quantity of S over square root of N, where S is referring to the sample standard deviation, less than population mean, less than X bar, which is referring to our sample mean, plus T sub alpha over 2 times S over square root of N. Okay? Then we are given also the X bar as 23.8 and our N is 15 and our sample standard deviation is 3.4. Then our DF is 15. 15 minus 1 because DF is N minus 1, so we have 15 minus 1 is 14. Then from the test table, so we have a corresponding value of 2.14 from 0.025 and DF which is 14. Okay? So by using the formula, our X bar is 23.8 minus 2.14 as our value for T sub alpha over 2 times our value for standard deviation is 3.4 over square root of 15. Less than population mean, less than 23.8, and the other side actually is referring to the maximum value where the population mean is being estimated. So same quantities from the left and right hand side, the only differ on the operation because from the left hand side we have subtraction while the other one is addition from the right hand side. Next to that, okay, so we have here the next one from 3 over 3.4 over square root of 15. If we're going to simplify that one, that is equivalent to 0.88. Less than population means less than same quantity also in the right hand side. Okay, then as we simplify between 2.14 multiplied by 0.88, so that is 1.88. Also the other side, but it is being added. While from the left hand side, 1.88 is being subtracted from our sample mean. Then, if we're going to simplify again, we get 21.92 less than population mean, less than 25.68. So it means that the population mean ranges from 21.92 to 25.68. Okay, so that is how to estimate the population mean using t-test. Okay, let us have now the problem 2. Telecommunication specialist wants to determine the proportion of prepaid subscribers in the Philippines. A random sample of 70 was chosen and data gathered showed that 25 are prepaid subscribers. So we are asked to compute the 90% confidence interval for the proportion of prepaid subscribers in the Philippines. So note, we are asked to use also the t-test table. So as if you're going to compare this second problem from the first one, so we use the t-test in the previous problem because our n at that time is less than 30, but at this time is more than 30. So we have a random sample of 70. So we have to use now the t-test table. Okay? So we are asked to compute the 90% confidence interval for this problem. So this is focusing on proportion. Okay? Estimating the population proportion. So of course, solution, our p hat actually can be obtained from what x over n, where x is referring to the sample or the data gathered from the sample. So we have 25 over n, which is 70 ang n. So 25 divided by 70 is 0.36. Okay? Then after that, our g sub alpha over 2. Same concept as what we have done in a previous slide, that in computing for g sub alpha over 2 and t sub alpha over 2, they are actually the same. So 1 minus 0.90 because 90% confidence interval man over 2, we have g sub 0.05. Ang 0.05 is actually referring to the actual area. The actual area from the G table. That is corresponds to a value of plus minus. We use positive and negative because we are focusing on estimation where we get the minimum value and the maximum value. So we have plus minus 1.65. Okay, so let us now use the g-test table on how this value being obtained. Okay, so we have, okay, our g sub 0. We have sub 0.05. Actually, if we're going to use the z table, that is corresponding to a value of 1.60, 1.65, because from the left hand side, from the tail, no, of the arrow, 1.6, and the upper one is 0.05. So if we're going to add 1.6 plus 0.05, that is the correspond to a value of 1.65. So as what we observe, we choose a value of 0.04947, because if we're going to round off this value using two decimal point, that is equivalent to 0.05. No? In the previous value, we have 0.05050. That value cannot be used because if you're going to get that two decimal, at the same time, if you're going to round off them using two decimal places. So therefore, that is equivalent to 0.051, and that is exceeding to 0.05. So we will have to use the minimum 0.04947, which corresponds to a value of 1.65. So we can now use the formula. We have p hat minus g sub alpha over 2 times square root of p hat times the quantity of 1 minus p hat over n. Okay, we have less than p hat, same quantity from the right hand side and left hand side. So of course we differ only on what the operation, because we subtracted, no, from the left hand side, then we added from the right hand side. Okay, so provided that our p hat, as we computed in our previous slide, we have 0.36, no, then our g sub alpha over 2 is 1.65. So therefore, we have 0.36 minus 1.65 as our value for g sub alpha over 2 times square root of 0.36 times the quantity of 1 minus 0.36 over 70. 70 actually is referring to our sample size. Then we have the same quantity also in the right hand side. So if we're going to simplify, square root of 0.36 times the quantity of 1 minus 0.36 over 70, that is corresponding to a value of 0.057. Okay, same as in the right hand side. If we're going to multiply also 1.65 times 0.057, at this time, do not subtract first 0.36 or 1.65 from 0.36. We have to use PEMDAS. No? We have to use PEMDAS. I know that all of you are familiar with that because you have been encountering that one when you were in grade 7 until grade 10. No? You encountered that PEMDAS. So meaning the order of operation. So we will have to, if there are exponents, we will have to simplify that one. Next, the parentheses, then multiply or divide before we'll add or subtract. So that is the concept. So we'll multiply first 1.65 times 0.057. So we have 0.36 minus 0.094. Same quantity also in the right hand side, but that is being added ang 0.094. Simplifying, we get 0.266 less than p less than 0.454. So we identified that the p ranges from 0.266 to 0.454. Okay? Okay, so that is actually the values for P. Ranges from 0.266 to 0.454. Okay, let us now proceed to problem 3. This is now determining the sample size for the population mean. Determine the sample size necessary to estimate. Okay, so in this problem, so we are asked to determine the sample size necessary to estimate the population mean. Using the following information, we have our population standard deviation is 0.36, and our maximum error of estimate is 0.2. So the maximum error of estimate is actually coming from the difference between the population mean and the sample, then at 95% confidence level. So again, our maximum error of estimate is coming from the difference between the population mean and the sample mean. Okay, so let us have now the solution. So the formula for identifying the sample size, we have n is equal to the quantity of some population standard deviation multiplied by z sub alpha over 2 over e raised to the power of 2. Okay, so we already have the value of the standard deviation, but the z sub alpha over 2 is not actually given, so we will still have to get that one from the z table. Same process as what we did from our previous slide. Okay, so for the z sub alpha over 2, actually we have that is 1.96, so we already identified that one in the first problem, I think. 95% confidence interval, same value, that is 1.96. Okay, at same process also. So our n is 12.45, or approximately to the next number, that is 13. So it must be a whole number now, because that is, we are talking about the sample size man, so it must be fixed, no? Okay, let us proceed now to problem number 4. So determine the sample size necessary to estimate P for the following information. So this problem is focusing on estimating the sample size for population proportion, wherein our maximum error of estimate is 0.02 and our p hat is approximately 0.40, and the confidence level is 96%. Okay, so solution, we have here the formula in estimating the sample size for the population. We have here our population proportion, n is equal to z sub alpha over 2 times p hat, okay, multiplied by 1 minus p hat, okay, over e to the power of 2. So let us now have first to identify the g sub alpha over 2 value. So we have 1 minus 0.96 over 2 is equal to, when we are going to simplify that one, we have z sub alpha, or z sub 0.02, where 0.02 is referring to the actual area in the z table. So the z value for that one is corresponding to a 2.05 value. Okay, so same process as we did in the previous slide in determining the g sub alpha over 2. Okay, so we can now use the formula. 0.40, actually that is being interchanged, so it must be 2.05 multiplied by 0.40, so nabaylo silang duha, but actually they are just the same. 0.40 times 2.05 times the quantity of 1 minus 0.40 over 0.02 raised to the power of 2. So if we're going to use our calculator or cell phone, we get a value of 1,230. So we have n is equivalent to 1,230 to estimate the sample size for P using 96 confidence level. So I hope that this example will help you, particularly in answering your assignment or activity, same as this one.